Good morning, everyone. Good morning, everyone. I want to welcome everyone to this year's Nigerian Parent and Interconnection Forum. And we are starting today with a bootcamp. We have a bootcamp series for today. We will be having two bootcamp series for today, one starting at 11 a.m. and the other starting at 3 p.m. Nigerian time. And we'll have two sections run for today. Tomorrow will be the conference for the NPIF, and we'd like everyone to join. Today's section and tomorrow's section will be a little bit technical and will be for those who have technical backgrounds on different stuff. And just to start, I would want to introduce the moderator for today. And the moderator for today's section is Mr. Albert Tata. Thanks so much, and do have a nice bootcamp.
Hello, good morning, everyone. Good morning, everyone, and you're welcome to this first session of the NGPI bootcamp series. And today's topic is actually going to be no-cost community services for network operators. But before we start, I would first of all like to give you a brief lowdown about our presenter today, who is in the person of Brian Davenport. Brian Davenport is a solutions engineer for outreach department of Team Cymru, and he has over 10 years of experience using metadata to improve network security and performance. And as a solutions engineer, he helps partners implement and understand all of the community services offerings that are available. And he's passionate about working with very smart people to solve very hard problems. That's very interesting. And also, he personally enjoys hiking through the White Mountains and traveling as much as possible. We hope very soon he will now start conquering the Red Mountains as well. That's our deserts. So you're welcome, Brian. And I believe we could just give you the mic so that you can just go ahead and start, because we are all waiting to see how you can dazzle us with all of these tools. Thank you very much.
Sure thing.
Go ahead, Brian.
Good morning. Can you hear me okay?
Yes, we can hear you quite all right.
Great. So I am getting I can't share my screen while you're sharing yours. So I think whoever is sharing the agenda, if you just stop sharing the screen, I'll swap over. So that looks good. All right. And we'll fire this up. And you're seeing that all right?
Yep.
Okay, great. All right, so good morning, everybody. Thank you for joining the first boot camp session here. Let me just get a little situated. What I'm going to do is just open up the chat in case anybody has any questions on the fly. And of course, there's the QA as well. Yeah, so we'll get right into it. So this will be a technical session, mostly around NetFlow data and flow data, how to set it up, how it works with some of our community services. We'll go into detail on that. So really the bulk of this talk is going to be around flow data, but I will, of course, introduce myself and my team. And again, good morning to everybody there in the chat. I see a whole bunch of good mornings flying in. So it's great to see everybody. And of course, thank you all for your time for watching this presentation here. So about myself, that was a great introduction. So I am a solutions engineer with Team Cymru. And I've been working with NetFlow data for about a decade. So through multiple companies, I've been working with the same protocol. And when I say NetFlow, right, that's going to be flow data like NetFlow or SFlow or IPFix or JFlow. But I'm going to go into a lot more detail about that, right? And I'm part of the outreach team here at Team Cymru. So we are a team made up of about 8 people right now. There's actually somebody else starting, I think, in a week or so. So it's a relatively small team. But what's really cool about outreach is that it's pretty geographically dispersed, right? So I'm up in Maine, which you'll see as the kind of upper right-hand corner of the United States. I have a couple counterparts. My boss is in California. One of my counterparts is in Florida, but then we have Sam over in Kenya. We have Tarek in Tunisia. We have Eirik in Poland. Tony is over in the UK, and of course, Giacomo's in Brazil. So the team itself is pretty spread out geographically, and we're responsible for doing webinars like this. So again, thank you for joining. We build a lot of solutions for the community that are all free to use. I'll go into detail on some of those in this session. And we host events around the world. So it's really kind of the focus of outreach is kind of in the name, right? It's to work with network operators around the globe to see what kind of problems people are running into and to try to make the internet just a better place overall, right? All right, so getting into the bulk of the technical discussion now. So I've been, as I said, working with NetFlow data for a very long time, right? And I've come to really like or love the protocol for a few reasons. One of which is it's a means by which somebody who has invested in network equipment, whether that equipment be MikroTik or Juniper or Huawei or Cisco or Arista or whatever your network vendor of choice is, most of these, if not all of them, have the protocol built in, right? So you already own it, you're just turning it on and then you're sending it to a NetFlow collector. It's completely passive. So you don't need to, like, for some solutions, you might need to install an agent. You might need to tap the network with like a span port, right? You don't have to do that with Flow data. You're just turning it on and you're sending it and then you're good to go. So the other thing that's really cool is when you start enriching the data with more metadata, you can get a lot more context. We do this with threat intelligence information, which I'll show you in a little more detail. But there's also the kind of network detective thing. So flow data is a great means to do incident response. If something happens on the network, right, you can kind of go back in time and see what happened. And it's a great way to trend, bandwidth utilization over time. It's just a great kind of tool in the toolkit that is very easy to get up and running. And I'll explain how on this talk, right? Okay, so there's really three questions I usually get asked, right? One is where and how should I configure my flow exports or the flow configuration? Like, what does that actually look like? And then people generally want to know, like, is turning this on going to impact the bandwidth of my device? And how's it going to impact the CPU of the device, right? So these are generally the three questions, when I'm working with people that I get asked pretty frequently. And it's been, multiple companies, 10 years, these questions keep coming up. So, on this talk, I hope you all find it interesting. What I'm looking to do is kind of cover these, get them answered, and then also kind of go a little more in depth into the flow configuration itself. So as I drink some coffee, it's 6 a.m. here, so a little bit early, but not too early. I've done a lot of these at like 2 a.m. So 6 a.m. feels very, very good for me. All right. So I think the first thing we need to do is just understand the different parts of a NetFlow configuration. So whether you're using MikroTik or Cisco or Juniper, your kind of experience in configuring NetFlow might vary, but the underlying concepts are generally the same across all exporters. There's typically a flow record, which is going to define what fields are going to be collected. And I have an example of what that looks like, right? So we'll go into a little more detail. And then you're generally configuring a flow exporter, which is going to define like where the flow data is sent and how it's transported. So like the IP address of the collector and the UDP port you're sending it on. And then you have a concept of a monitor, which binds together the record and the exporter, and that gets applied to interfaces. So why I say your experience might vary a little bit is that, you might have like something like a Palo Alto firewall as an example. Most people are configuring that in the GUI where you're clicking a couple buttons and enabling flow data. If you're using, I think, Winbox with MikroTik, the experience is kind of the same. You go to like flow monitoring and you kind of pick your targets and you turn it on. But if you're using like Juniper or Cisco, you might be doing it more in the command line. But really, regardless of the vendor, right, the actual underlying concepts of NetFlow configurations are kind of the same, right? So if we look at a flow record, if you're familiar with maybe Cisco or Juniper or some other like Huawei command line arguments, you'll typically see statements that look like this, which are like a match statement. And then you'll see statements which are like collect statements. So the difference between match and collect is a concept kind of, it's known as like key fields and non-key fields, where a key field is something that in a network communication, so say I'm communicating to a server, right? My source port is going to stay the same. The destination port should stay the same. The source IP should stay the same. The destination IP should stay the same. So those are kind of the key fields that if they were to change, then I would know that that connection ended, right? And I can stop metering it and I can export it. But a non-key field, a good example would be something like bytes, right? As I'm communicating with that server, the amount of bytes I'm sending to it are incrementing, right? So if I made bytes a key field, right, by saying I want to match counter bytes instead of collect counter bytes, then every time the bytes field changed, a new flow would be generated, which is not what you want, right? Because you'd just be generating tons and tons and tons of net flow, where really what you want to do is think of like in a TCP or UDP connection, what fields are constantly changing. Those are going to be your non-key fields. And then the stuff that should stay static are your key fields. A lot of vendors just take care of this for you when you're configuring it, because you might just say like enable NetFlow and you get a static NetFlow record. But some vendors allow you to customize that, right? So really there's tons of variety in what you're able to collect, right? Some devices are more flexible than others. And generally when you're looking at like NetFlow version 9 and up, so like IPFix or whatever, you're going to have more customization available, right? And then it depends on the vendor to report on what you're sending. The exporter is usually done on the global configuration. So this is going to be the IP address where you send the data to, right? The UDP port, you're going to send it over. And then it's going to be, typically you're going to be picking the source interface of the, that you want the flow data to leave the device from, right? I don't have an example of what this looks like, but those are basically the three things that comprise the exporter. And then your flow monitor is what's going to bind both of those things together, the exporter and the record, and it'll be applied to each interface you want to see traffic for. So you can think of a flow monitor as like on this interface, right? I want to observe this type of traffic, which is the record that I've picked. And I want to send data to this collector, which is the exporter, right? So we bind together the record, the exporter as a monitor, then apply that monitor to a interface. Common lingo for this, you might see it as like input, output. You might see inbound, outbound, or ingress, egress. Depending on the vendor, they kind of change the terminology. But regardless, there's a concept of input and output that's important to understand with a flow monitor. And I'll go into some detail on that as well. Okay, so I think really understanding these key concepts is a good starting point. What we can do is we can take a look at it as an actual NetFlow record in like Wireshark or a packet capture, right? So here's a flow record, right? And you can see this is just in Wireshark, basically just sending NetFlow to a collector and then running TCP dump on the interface the flow data is coming into, and then just decoding it as CFlow in Wireshark. And you'll be able to kind of look at the raw NetFlow records. So if we look at this, right, we have the actual data of the NetFlow record down bottom. But if you look up top at the actual packet here, right, you'll have the layer 3 and layer 4 information. So when we were talking about the exporter, right, that's where you're going to define where the flow data leaves from, where it's sent to, and the port it rides over. So you can actually see in Wireshark, right, or if I'll just blow that up so it's a little bit easier to see, right, if this is our kind of configuration, the source IP address is the interface of the router that's that you're exporting the NetFlow data from. So this is going to be very different from the monitor, where the monitor is where you're like, I want to observe traffic coming in and out of this interface. The exporter is just send it out of this interface. send it to this collector, and then pick a port that you want to send it over. So in our case, right, with our community service, we just open UDP 8888 by default as a port to send on. So you'll see that in this particular example, the destination port is 8888. But 2055 is pretty common. 6343, I think it's pretty common. Really, most collectors, in ours too, if you want to send data on a different port, you can change it. This would just be an example of the flow exporter, right? So that's kind of at the higher level where the data is coming out of and where you're sending it to. Now, if we look back at that record, right, and we blow up this kind of flow portion here, right, this is the record, right? So if we take a look at this, right, we can see we have this particular information that's coming in this flow where we have our kind of key fields, right, which shows us our protocol, source, and destination address, right, the source and destination port. And you can see these match statements over to the right signify and kind of match up to what we're getting in the flow record. So if these being key fields, what that would mean is like, if I start sending, if 199.232.114.73 was to send to a different destination address, well, that's a key field that would be put into a new flow, right? But if this communication keeps persisting, what's going to happen is if we look at the collect fields, right? Things like the time, right? So time is constantly moving. So we're collecting time. We're collecting the number of packets that are transferred because those are constantly going to be incrementing. We're collecting the number of bytes. Net flow, you'll see it as octets, right? But typically when you're looking at traffic rates, you're not looking at like octets per second. You're looking at bytes per second. So most NetFlow collectors will do the math to get you to bytes. And most configs will say bytes. They're not going to say octets. But here would be an example of things that would be allowed to change. You'll notice that I'm collecting the interface output. So you could match the output interface to say like, if this traffic starts going out of a different interface, put it into a new flow. Most of the time I'd recommend collecting that because you might be like load balancing or just the path would change and you want to stitch that as a single flow, right? So like if the egress point changes, just collect that and keep track of it, but don't generate a new flow if it changes, right? Okay, so that's our record. And then lastly, we have this concept of the flow monitor. And typically this is where things get a little bit confusing, right? Because understanding where I'm going to send the flow data to is pretty simple. I pick an IP address, a port, and then I pick an interface on the device to send the data out of. The flow record concept, it can get extremely complicated depending on like what you want to do. There's depending on what equipment you have and the metrics you want to get, there's a lot you can do with it. But for the most part, people are just, what I find is just like, using the generic template that the device offers. So basically you're not even defining your own template. You're just saying, send version 9 or send IP fix. And there's these defined fields that are going to look very similar to what you're seeing here, right? The monitor is where there's more questions, right? Because if we look at the flow monitor, actually, I do have a slide here. Sorry. So this is the first time I've done this slide deck. This is brand new for you guys. I hope you appreciate it. But it's a little, sometimes it gets a little clunky where I don't have the rhythm exactly. But I wanted to just take 1 second to highlight the key fields and the non-key fields, right? Just to kind of drive that point home. So if we have a packet that comes into a router, right? And a router decides to meter that packet or to route that packet, then we're going to start building our flow cache, right? And so what we'll see here is if the same the key fields of the packet are staying the same, right? We'll increment the non-key fields. So in that example, you could see all the IP address, right? The port, the interface information, the protocol all stayed the same, but the bytes were incremented because the packets were coming through as the same, right? Now, so we have another packet that comes in, right? Where the dest address and the source address are different. The router now knows, oh, hey, that connection ended, right? I can bundle it up and send it as flow data, right? Out this interface to a NetFlow collector. So that's just kind of an example of showing, right? How if a connection persists, we're incrementing the non-key fields, but once those, match statements, if something in there changes, we're going to know to export that flow data and the connection will end, right? Okay, so now let's talk about the flow monitor. So if you guys are alive in the chat, this is how I can tell if people are paying attention or not. What I'm going to do is I'm going to show just a connection here from this user to this cloud. And I guess I'll ask a question when I do this, right? So if this user sends a connection to the cloud and the cloud responds back, the question would be, if I only have a input flow monitor, right? So I have defined my exporter, I've defined my record, and then I put an input flow monitor in interface 1. For that connection, how many flows would I see, right? So I have a packet going from the user to the cloud, and then from the cloud comes back out that interface, and I have an input monitor. So if you want to participate, I'm going to answer this question in about 10 seconds, but you could answer in the chat. You would see like something like 1 for 1 flow record, or 2 for 2 flow records, or 3, or nobody has to answer, and I'll just, sit here in front of the camera and assume that people are out there. Okay, people see 1. Okay, great. Yes, you're right on, right? So I only have an input monitor. Thank you for the participation. It's, when you're in your room by yourself and you're just talking to a camera, sometimes it's really nice to see that people are out there. And you're right? So everybody here is right on, right? I see a single record, right? And I exporting a single record. Now, what's important here is because I only have that input monitor, right? I'm actually not seeing the return traffic represented, right? So in the flow record that I do see, I can infer, right, that the traffic went out interface 3, right? But what I see is, right, I have a source IP here, source port, which is me, and I'm destined here on port 80. I come into this interface, flow records. Remember, I can collect the outbound interface, right? So I can see it did go out this. I see the protocol, and I see the total amount of bytes. So what I could do is I can infer bandwidth utilization and say, well, I got 100 bytes coming in here, right? And 100 bytes going out here. But I don't know how many bytes were sent back from the cloud, right? So what I could do, right, is I could add an input and an output monitor. So I would typically ask, like, how many flow records am I going to see here? If you want to throw a number in the chat, I think based off you guys answering the first one, you're probably going to get this, that it's going to be 2. But right, so now I have an input and I have an output monitor, right? Cloud responds back. Yeah, Kingsley, you are right. Thank you for your, it's 2. So now I'm going to get 2 records, right? And the difference here is, the first thing is, notice the source and destination IP address and source and destination port flip, right? So now I see I have, from this interface where I'm metering, right, I have my input monitor, which is the top, right? I can see there's 100 bytes. And then the flows come over here. Now I don't see the traffic coming inbound to this monitor yet because I haven't applied a flow monitor there. But what I do see is, as the data comes out of interface 1, right, I can see there was 400 bytes, right? Which means, if you think of like a web request, typically, you say, give me this web page, which is a small amount of bytes. And then the web server serves you back the web page, which is going to be more bytes, right? So I can see that I received 400 bytes of data, and then I can see the interface it came from, right? Now, here's where things start to get a little bit even stranger, right? So if I apply now an input monitor to this interface, and I leave my input and output interface, right, monitor, and we fire this off, kind of speeding up the transfer. So now, like we're seeing, right, I'm going to see 3 flows, but also something kind of interesting happens is I start to see duplication, right? So again, our first 2 rows are going to be our input output monitor. And then our third row, right, is metered ingress on interface 3, but it's going to be the same data, right? Because it comes in here. This is, of course, assuming that the router doesn't do any compression or make any changes in the middle, right? It's going to be the same. So really, I'm generating 3 flows, but 2 of them are going to be the same because I'm monitoring input, output, and then input. And then, of course, right, if I do input, output, I'm going to go up to 4 flows where really I'm duplicating them twice, right? So I'm going to go into why you would use input, output, and why you might use input. But I just want you to kind of understand, right? And I think it's kind of helpful to maybe to break it down this way when you look at it. So, kind of like step by step, you can really see what the router's doing, what the router's thinking as you're applying these flow monitors, right? So really the question that was originally kind of this common question that gets asked is like, well, where do I enable this and how do I enable it, right? And typically what I say, or what I see is, or what I recommend is just do an input flow monitor on all interfaces on a device. If you want to see traffic on every interface for a device, put an input monitor on every interface, because then you're going to see traffic going in and out of every interface. You won't be duplicating any traffic, right? And you're going to get full reporting on all of the devices. If you want to use input output, typically what I would recommend there is if you only care about maybe one or two interfaces, right? You don't want to monitor all of your interfaces, but maybe you have like some funnel points where all of the traffic's going in and out of, and you only want to see traffic for maybe a few, of your big like WAN links. Well, then you can put an input output monitor on just those interfaces, and you'd see all the traffic coming in and out of them. Just be aware, right? If I only have an input output monitor on this bottom interface in this router, if peer 2 communicates to peer 3 in this example, I'm not going to have any representation of that traffic, right? Because it's not going through the interface I have the monitor applied to. Coffee, 1 second. Another argument for egress monitoring is if you are interested in observing middle box functionality of a device. So what that means is something like a DSCP marking, right? Or a quality of service marking changing. I think I have a slide on this. I'm going to go to the next one. Yeah. So in this case here, we're looking at that kind of previous slide where I have an input and output monitor. And I just added a couple more columns, right? So in this case, the user went into the configuration, right? And they're matching on the DSCP marking, right? And also the flow exporter is telling us the metering point, right? So here I can see as this packet, right, came inbound to interface 1, it was marked with 46 EF, right? And then when it came, oh, actually, you know what? This is not correct. So these are the kinks I'm gonna work out here. But this second line should say uncategorized, right? So what the example would show us is the traffic came inbound, marked 46 EF, and then the next 3 would be the outbound, right? As uncategorized. So really what's happening is packet goes into this interface, and then it leaves interface 3 as uncategorized. So look at basically row 3 and ignore row 2. What this would tell us is in the middle, right? The traffic came in marked the way I wanted it to. Then in the middle, the router basically stripped off the DSCP marking. And as it egressed interface 3, it went out uncategorized. So these are both, the middle 2 are my egress monitors, right? If I look at that, so say you were only monitoring inbound here, right? So 1 and 3. If you saw something leave as 46 EF inbound to interface 1, and you only have an inbound monitor, and you saw that traffic come inbound to interface 3 uncategorized, you would not know if the router removed the DSCP marking or if something upstream from you removed the DSCP marking, right? All you would know is it came in interface 1 marked and it came in interface 3 unmarked. If you have an outbound monitor on interface 3, right, what you would see is it would come into interface 1 marked, and then when it left interface 3, it was unmarked. So then you're capturing both of those points, and you know that the middle, right, is where it changed. If you're only doing input, you wouldn't know if it was the middle or if it was some other router downstream that made the change. I have to clean up this slide a little bit. I think that's a little bit confusing, but it's a pretty niche use case of when you would want to use ingress egress. Another example would be maybe if you're doing like WAN compression or WAN optimization, right? Where you're compressing traffic in the router and sending it out. If you wanted to visualize that compression, that's another good example for using, like, you can see traffic comes in with this amount of traffic, gets compressed, and then leaves at this amount. Otherwise, generally what I recommend is just do input monitors everywhere. That's going to be your simplest configuration, and you're going to see all of the traffic. Only if you care about a few interfaces or you want to observe that middle box change would be a good reason to use egress. This is my opinion. Another thing would be you could use input output everywhere and then have a flow collector that handles the deduplication of the traffic and the stitching and figuring out how everything interacts, right? Depending on the flow collector, it may or may not do that. Generally, input everywhere is a good starting point, right? Okay, so that's just a breakdown of really how flow data works and how it's set up. Now, the three questions from the beginning, right, were how do I configure this, right? The second one was, how's it going to impact my bandwidth, and how's it going to impact the CPU of the device? So regarding the bandwidth, really, if we looked back here, it's very efficient for bandwidth utilization. And the reason for that is because of the relationship of key fields and non-key fields, where if I have something like a data replication, right, or backup, that's like, a terabyte or 2 terabytes of data that's being backed up. If the source IP, right, and all the key fields stay the same, I could represent that in a few flows, right? It's this IP to this IP, and it's sent 2 terabytes of data, right? So it's not like packet capture where you're pulling all of that data across the wire, right? If you're using like RSpan or something like that, it's a very efficient summarization of the data. So typically for bandwidth, you're going to see like maybe a 5% bandwidth uptick by using flow data. But your mileage might vary. You can always do things like sampling if it affects your bandwidth, but generally it won't. And then regarding the CPU of the device, I've been doing this for a long time, and in the last 5 or 6 years, I've never seen turning NetFlow on impact the CPU negatively to a point it's going to like reboot the device. I have run into that, probably 6 or 7 years ago, but devices are so efficient now. Even like microtik routers that cost a few $100 can do NetFlow, right? Unsampled, you can just turn it on in production, it'll work. So it's very efficient regarding the CPU as well. So generally, bandwidth isn't a concern, CPU isn't a concern. The biggest, I think, thing that needs explanation is how ingress and egress monitors work, how to build a NetFlow record, and where to apply it. So that was kind of the goal of what I was going through here. And definitely I can answer any questions on NetFlow either on this call or, if you're on LinkedIn, definitely find me on LinkedIn. I'm Brian Davenport on LinkedIn and connect with me. Mostly because I like to connect with the people that I'm presenting to, but also if you have more questions you want to ask me, feel free to do that. So I'd be remiss, right, to kind of go through this all explanation of flow data. And then what I do want to mention is if you don't have a means by which to collect data, or you're curious about maybe, trying it out, or you kind of want to see what we have to offer, part of what we do in outreach is we build solutions that are free to use for the community. One that we have is called Nimbus TM, and this is a cloud-based NetFlow collector, right? And it's free to use for ISPs or hosting providers or CSRT teams. So you just sign up for it, and we spin up a cloud instance, and then you can send NetFlow data to it and start visualizing traffic. And really, the special sauce is if we kind of look at that original packet, right, that we were playing with in our previous example, what Nimbus will do is it will take the flow records, and then Team Cymru has a been around for 15 years, and threat intelligence is really the bread and butter of Team Cymru. So what we're going to be doing to the NetFlow records is adding some more context to them around threat intelligence and some information about ASN. So here you'll see, right, the destination ASN and the source ASN actually have the name. So we'll look the IP address up, right, and we'll name it to the ASN. So it becomes a lot easier to see what's going on. And then over to the right, you'll see you have a concept of an alert IP, a signature, and a confidence score. So those are added in, and this gives you really a GUI by which you can take all of your network traffic and see, well, of my network traffic, what percentage of it is malicious? And if it's malicious, what botnet was it attributed to, right? What router did it go over? What partner did it come from? So it's a really clean way to just send the flow data into Nimbus, mark it all, and you can start to see, like, do I have like compromised assets on my network? If I do, like, what botnets are they communicating with? What time of day is it occurring? What percentage of my bandwidth is bad traffic? Or maybe I'm selling internet to somebody and, I want to let them know, hey, you have, your entire network is communicating with Conficker or something along those lines, right? So you can kind of send a report by filtering on traffic by autonomous system. So you get kind of these GUI views like this, which are really nice, super easy to use and click into. And then also Nimbus will give you the actual flow records that are, marked with this data, right? So here would be an example of a row where you have your, source IP, source port, protocol. Again, that concept of key fields and non-key fields we're talking about. It's all just right there as a raw flow record where you can go in and actually look at it as a table view or pull it as a CSV or something like that. So Nimbus, definitely, if you're interested, check it out on the website, sign up. And, even if you want to check it out for a week or whatever, you can do that. But most people end up using it for a while. And I'll have some links to that at the end of the presentation. Okay, moving along, we're going to getting close-ish on time. So I want to be respectful there. Aside from Nimbus, though, so this is kind of moving out of our NetFlow talk, right? There's a bunch of other free stuff you can find on our website. I'm going to go into one more in a little more detail just to wrap up my presentation here. But be aware, right? We have a whole bunch of stuff like the Bogon reference, which is extremely popular. Many of you might be signed up for that. I'll just kind of, toggle this slide a little bit so you can see what each one does. Dragon News Bytes is a great mail list to be a part of. Bogons, of course, is a great way to kind of see, what IP addresses shouldn't be out on the internet. But what I'm going to talk about in a little more detail is udders, which is this cow icon. And the reason it's got I call it udders now, but unwanted traffic removal service is where you get the udders, right? So that's where you get the cow. It took me a little while to get that. But anyway, I'm going to go into this one in more detail because we have udders 2.0, which is our new version coming out very shortly, hopefully this week, actually. So I'll go into a little detail about udders, how udders works. And then if you're interested in that as well, you can sign up for that on our website. So the idea behind udders is it's a community approach to DDoS mitigation. Dramatic pause, 1 second. So what makes it kind of community driven is the fact that all of the network operators are working together to honor the announcements of other ones. When somebody says, hey, I'm under a DDoS attack, stop sending traffic to this IP address, as opposed to like doing a remote trigger black hole to just your upstream. What udders will do is we'll make the announcement to the entire community. So each network operator can sinkhole the traffic or black hole the traffic or null route the traffic, however you want to say it, locally at their BGP router, right? The way this looks kind of graphically, right, is if we have a network like this, right, and we'll say this victim is under attack here, right? So I have all of this bad traffic that's coming in from our attackers, consuming the internet pipes, right? The strategy we might have at our hands is doing remote trigger black hole. So I make an announcement to my upstream. Now this has some caveats where, first off, the upstream provider has to offer remote trigger black hole as a solution, right? The second thing is it kind of makes it so the DDoS is successful, right? Because basically you're saying, hey, service provider, take this, stop sending traffic to this IP address. So in effect that, the DDoS works because that service is now offline, albeit you may save your network, right? Because your router that's in front of that is is now not getting overwhelmed by the traffic. So it could be a good solution there. But the other thing to consider is all of that bad traffic is still going across the internet, right? So all of the other people in the community, right, are still getting this traffic, right? So there might be other small network operators, right, that are getting overwhelmed by this DDoS. And really, the whole thing is, right, as network operators, our job is to make the internet better if we can. And this traffic is just pointless traffic. It's going to get null routed at the your service provider anyway. So it's just meaningless traffic now that's going across the internet. So what if instead of just doing the remote trigger black hole, we make the announcement to a trusted source, and then that announcement gets propagated out to everybody in the community, and locally they decide, I want to black hole the traffic. That's what Utters is, right? So Team Cymru is just a trusted source by which we vet everybody that comes into the community, and everybody in it honors the requests of everybody else, right? So in this case, AS65540 makes the announcement to Team Cymru, and then we propagate that out, right, to everybody else in the community. And then locally, they're going to start blocking the traffic. So here, you kind of have that same question of, well, isn't this still making the DDoS accomplish its goal, right? The traffic stops going to that victim. So the answer to that is yes, but in Utters 2.0, we have some more knobs you can turn, right? Some more dials you can turn, which I'll go into. But also just the difference between remote trigger black hole and Utters is just look at the volume of blocking this traffic, right? You're taking it out of the internet closer to where it started, right? So with Utters 2.0, which is coming out, we're going to be adding support for FlowSpec. If you're familiar with FlowSpec, you might be kind of nervous of this thing that has a bad rap where if used improperly, it can cause problems. We have a very strict policy with how FlowSpec rules are honored and implemented. So an example would be, you could say, like, stop sending traffic to this destination IP address in that example before, but stop sending traffic if the destination port is like port 80, right? So you can more narrowly define, maybe you have a server that's, hosting a web app, but also doing like DNS and maybe SMTP or whatever, right? Those other ports would still be reachable. It would just be, you're saying, don't send it on a web port, right? So FlowSpec gives you more dials with, like, you can say, define source port or like a source address or something like that. So more like an ACL, but BGP focused. We're going to be doing RPKI validation, another means by which we can, authenticate the announcements. Also, this, if it is a signed ROA, right, your upstream could make an announcement on your behalf. So now people that are in the DDoS mitigation kind of space. Sorry, I just saw a question pop up. I'll get to that in 1 second. And writing in support for IPv6 and larger prefixes. So IPv6 is huge for our community because we're very spread out internationally, and IPv6 is huge in a lot of parts of the world. So adding that in was a big step for people that are running IPv6 networks. And then Nimbus, which is our NetFlow collector, we're making some very large architecture changes, which are going to help us scale. Nimbus has become insanely popular. We kind of thought that there might be a need for like an easy to use, lightweight NetFlow collector. I think we might have underestimated exactly how many people were going to be interested in it. So it's like, the thing with architecture changes, you don't really see it in the front end that much. But it's going to help us, help more network operators. It's going to make sure we can continue the program. And then also we're looking to modify some of the workflows and maybe add additional data types. So part of doing these presentations is to kind of, show people what we're working on. But also, if you end up signing up for Utters or Nimbus or any of the other community services, we're generally working with you to figure out, like, well, how do you want to see the data, right? What's important to you guys, and taking that feedback and then making those changes as best we can. So really, part of this is not only to explain how flow data works, but also kind of encourage you guys to check out our community services so we can continue to make them better, right? And that is it. So I'll take a look at some questions. I just want to first off say thank you so much for your time, right? This world is insanely busy. everybody is just busy, 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 busy. So anytime anybody will sit down and listen to me talk for, 46 minutes or so, I really do appreciate that. So thank you very much. Just want to say that. Please do check out some of our community services. You can go right to the website, just sign up for them. There's a little bit of a vetting process, so you might have a little bit of delay from sign up to when you get like your login credentials or your BGP information. So be patient, but please sign up for those and check them out. Check us out on social media. And then if you are on LinkedIn, one of my favorite things is coming off a presentation and seeing all the wonderful people out there that I just talked to. So please feel free to connect with me. I will accept your connection requests, and I look forward to meeting you. Okay, so we have 2 questions, I believe. Nope, one was not for me. So that was more on the attendance. Okay. You guys are, thank you so much for the kind words. You're very welcome. Here we have a question here. Please, can you explain higher why latency between my ISP and my enterprise network? Someone's asking for a certificate of attendance. They're getting a response there. So I think the question is, can you explain why latency between my ISP and my network? Yeah, so this is an interesting question. So I should put this in a common question that I get asked. So sometimes people will look at flow data and they'll ask that question, like, right. So I saw that this transfer happened, but how much latency, right? How much latency was there? So flow data can do that. Specific formats of flow data can do that. There's things like performance monitors, which is a very kind of boutique or unique NetFlow configuration where you can say like monitor the latency of a connection. And really what the NetFlow is doing there is it's saying, basically what it's doing is like in a TCP connection, you have a SYN flag that goes out, right? Then you have a SYN-ACK that comes back, and then you have an ACK. That's your 3-way handshake. So how that will work is what the router will do is when the SYN flag goes out, it starts a timer, and it says how long after the SYN flag was sent did it take for that SYN-ACK to come back, right? And that shows me my server side latency. Basically, I saw the SYN flag at this time. How long did it take for the ISP to respond to me or my service to respond? And then the ACK, right, back from your client is your client side latency. So after I saw the SYN-ACK, how long did it take for the ACK? That's a very kind of, you have to have a specific kind of like Cisco router to do that. What I normally say is NetFlow isn't going to give you latency for the most part. It's going to give you bandwidth utilization. So how much of my link is utilized, not how much latency am I seeing on a link, right? It's not really designed for that, the protocol, albeit you like, I never say never because you can, but for the most part, you would be able to see if people are complaining about slowness, you could look at NetFlow and see, well, my link is pegged at 95% and there's a giant backup that's happening right now. So that's probably impacting the latency, but it's not a true like metering of latency. It's not like, synthetic monitoring or anything like that. Hope that answers your question. So as far as the copy of the presentation, I can't give you the slide deck, but I believe this is being recorded, so you'd be able to watch it again. So hopefully that helps you out there. I think that is it. I'm looking. So I think that's all the questions and that's all my time. So I'll turn it back over to the host. Stop sharing here.
Thank you very much, Brian, for that wonderful presentation. And just one last question, maybe, I don't know if I could ask this. When somebody now enables this flow diagram, flow collection, and he end up having to send it across to Cymru, and of course, we know we have issues when it comes to bandwidth. We don't have enough bandwidth. So, like, how much of that does that impact on the bandwidth that we already have? I mean, people will not start asking questions. Okay, I don't have enough bandwidth, and how much of that bandwidth is not taken?
Yeah, because the protocol is, well, there's two things, right? So typically bandwidth is very small, like 1% of your bandwidth or 2% of your bandwidth is flow data, right? Because it's just, it's, a single flow can represent gigs and gigs of traffic because it's just showing, this IP to this IP sent this amount. So people generally ask that because they're thinking like, am I sending all of my traffic? Because then I'm basically like, if I'm doing a gig, I'm sending a gig, right? NetFlow has no payload. So it's only the packet header, and it's not every packet header. They're summarized, right? So it's a very, very efficient protocol. The other thing is once you start sending flow data, the other devices will start seeing the flow data and reporting on it. So, commonly what people will do is they'll start sending flow data and then they'll look at their NetFlow collector and see, well, what percentage of my traffic is NetFlow? Typically, it's a very, very small percent. So I'm never really concerned about bandwidth as an issue.
Thank you very much. I think we still have, we just have about 8 minutes to the end of the thing. Yeah, exactly. So if there are any other questions, people can just ask the question. I can just utilize the last 8 minutes. If not, then probably could call it. Let's see. Any question? So please, participants, if you have any questions, you can raise up your hand and just ask the question. So, and I encourage us to all of to actually take advantage of all of these things that we have to offer. You can see the community services applications are actually quite free, and people can actually use it. So, like, please let's use that and use that to monitor our network so that we can have a better network. Somebody was talking.
Yeah, I was talking about the Nimble Thread Monitor.
Okay.
So do we have it like an app that requires internet to run, or does it feed to a cloud, or is it that you can use it locally?
Yeah, so it is cloud. It's cloud-based. So it would come out of the router over the internet into Nimbus Threat Monitor. So you'd have to have a means by which to export it over UDP to the internet. There is some instances where we've done it locally, but typically those are very kind of rare cases. For the most part, people are using the cloud version.
Okay. But I will be having my traffic on cloud and traffic of my users on that cloud. What is the privacy there for me, knowing that I, as an ISP, I have my users under my own privacy alone, not having someone on the cloud to access to my traffic?
Yeah, so we get that question from time to time. So Nimbus it's GDPR compliant. We worked with lawyers both in the States and overseas to ensure that, we were enforcing GDPR policies. But the other thing is NetFlow is going to be, right, really at its heart, it's IP address and port. So you don't have the data is anonymized in the sense where you don't have subscriber information, right? Where it's attributed to an actual subscriber or credit card information. It's just the header. So that kind of helps with the anonymization of it, where it's not, subscriber data as much as it's just kind of metadata about the traffic that's going through the network. But that's a great question. We do get asked that a lot.
Okay, thank you.
No, thank you very much.
Yeah.
Well, thank you very much, Mr. Yunus Abdurrahim, for that wonderful question. Any other question? If not, I think I'll just pass it over to Joshua. Joshua, if you're there, probably need to give us some.
I just want to say again, thank you all. I look forward to watching the rest of the presentations. Have a great rest of your day.
Thank you very much.
Bye,
thank you very much, Mr. Brand. That was a wonderful presentation. We hope to have you next time if we are having any talk again, and we hope we're going to come on board to come and educate us more. Thank you very much.
Thanks so much, Mrs. Atta. Thanks so much, Brian, for the section. It's been well educative. I hope to try this NetFlow on our network, and I'm sure the ISPs will want to try this also. This is going to be we're wrapping this section and to be the end of this section. We have another bootcamp section today by 3 p.m. You can just sign in the same link The section by 3 p.m. will be the section about BGP, how to integrate BGP on a network. It will be done by Huberto from Twitter. And then after that section, we have a section on how to integrate IPv6 in your network. And that will be done by the Afinic team, which is Willie Manga and Bryce Abba. So feel free to join that section by 3. It has same link as after this meeting. And also we have the NPIF conference. The conference itself is tomorrow. Same time, 11 a.m. We wish to see you tomorrow. And then the last section will be on Thursday by 11 a.m. The section for tomorrow is 2 hours. The section for Thursday is 1 hour too. We hope to see you tomorrow and next tomorrow, and also this evening if you have time to join the IPv6 and the BGP section. Do have a nice day, and thank you for joining, and see you by 3 p.m. Thank you. Oh yes, one more thing I forgot. I forgot to thank the partners for this section. So for this section, we have the Flex Optics, Facebook, and Internet Society and Rack Center as partners for this, and we are grateful for their support and the support to the internet. Once more, thank you so much, and do have a nice day ahead. Feel free to check the website if you have any issues, and feel free to send us emails if you have any issues, and we'll happily respond to them. Grateful.